All right, on page 492 today, down there at the bottom, corollary 7.1. Proportional parts of parallel lines. If 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. Three or more parallel lines. If 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. So basically, we want to take 3 lines and if they have the red arrow on them, then those 3 lines are parallel to each other. So there's the first part of the theorem. 3 or more parallel lines intersect two transversals. So if we put a transversal here, and then another one here, call the transversals L and M. They divide the transversals proportionally. What that means is if we label these vertices going down this left side, ABC, and then going down the right side, DEF, then this segment AB over BC is equal to, what's AB over BC going to be equal to? DE over EF. Very good. All right. All of these pieces are going to be proportional. Now, since they're all proportional, someone brought this up yesterday and I wanted to mention it as well. Look down this left side. All right, we basically said that the small piece on the left over the top piece on the left over the bottom piece on the left is equal to the top on the right over the bottom on the right. What else is true is AB, this segment AB, over AC, which is the entire piece, or the two pieces combined, AB over AC is going to be equal to, what's AB over AC going to be equal to? DE over DF. Very good. All right. So that's the combination piece over the top piece equals the combination piece over the top piece. Does that make sense? all of those proportions will be true. Okay? Any questions on that concept? All right, then over on the bottom of 493, congruent parts of parallel lines. If three or more parallel lines cut off congruent segments. On one transversal. Then they cut off congruent segments on every transversal. Three or more parallel lines cut off congruent segments. So the first thing we would need drawn the diagram is three parallel lines. So all right, and we're going to call these three parallel lines. That bottom line's a bad example. Let me get that closer. All right, three parallel lines cut off congruent segments on one transversal. So if we put a transversal in here, and we say that this segment is congruent to this segment. Three parallel lines, and along one of the transversals, at least two pieces are congruent. What the theorem says is if there's another transversal then these pieces in that transversal would be congruent to each other. So if AB is congruent to BC, segments along one transversal are congruent, then CD would be congruent to DE. AB is not going to be congruent to CD, but AB is congruent to BC and CD is congruent to DE. Any questions on that concept? Congruent parts of parallel lines. All right, take a look at the top of page 494. Let's do example 5. And we've got 3 parallel lines. And they're cut by 2 transversals. We're told that this piece is congruent to this piece. The 3 lines are parallel. Then up top we got a JK and an L. J to K is 6x minus 5. K to L is 4x plus 3. M to P, that's 3y plus 8. And P to Q, 5y minus 7. All right, and if you have to find x and y, now if MP is congruent to PQ, what do you know about JK and KL? They're congruent to each other as well. So in order to solve for x, we can say that 6x minus 5 is equal to 4x plus 3. Can subtract 4x from each side. So 2x minus 5 is equal to 3. Good. Add 5 to each side. Two x is equal to 8. And then x equals 4. Solving for y, we're going to set 3y plus 8 equal to 5y minus 7. Subtract 3y from each side. So 8 equals 2y minus 7. Add 7 to each side. So 15 equals 2y, and then divide both sides by 2. So 7.5 is equal to y. All right, so anybody have any questions on either of those theorems or concepts? All right, then your practice for today is going to be on page 495. Problems 1 through 9.